Hey boys and girls, so today is Unit 4, Lesson 7, which is the triangle congruencies. All right, first thing you're supposed to do is write your name at the top of the lesson. Once you've done that, you should be working on the do now. I'm gonna run things a little bit differently. For this lesson, I want you to work on the do now on your own first. Test your knowledge, see what you know at this point. This is a really challenging unit. And then at this point, just press pause on the video. And then when you're done with the do now, you can press play again. And then I'm just gonna go over with you the answer to the do now. Okay, so I already went ahead and I looked at the givens. I highlighted the two triangles that I'm trying to show that are congruent, which was triangle ABC. Originally, this was all in yellow. And then I highlighted triangle DCB, and this would be all in orange. I can see that I have an overlapping colors down here. That's gonna be important later on, okay? As I look at the givens, I have 3 of them. Here's number 1, comma, here's number 2, comma, here's number 3 at the end. All right, I wanna make sure that I'm using all 3 as I'm going over this question. So if I look at the first 2, they have the perpendicular symbol. Perpendicular lines form 90-degree angles. All right, so I know that I have to add the box where line segment AB and line segment BC intersect here. So we have AB, BC. That means my 90-degree angle box is going to go in this corner over here. If it's helpful to you, you can redraw the triangles that we're trying to prove congruent. A lot of times that's easier to look at them separated instead of overlapping like the original diagram here. All right, so I'm gonna also add the 90-degree angle on my separated triangles as well. So that was number 1, I added it. Now I'm gonna look at number 2, line segment BC and line segment DC. BC and DC are here. So I have a second right angle in this corner as well. And I'm also gonna add it on my separated triangles too. All right, as soon as you mark something on the diagram, you immediately need to add it to your table here. So step 2 is going to be angle ABC, right? ABC, that's in my first triangle, is congruent to angle DCB, right? DCB in my second triangle. And how do I know those angles are equal? Because perpendicular lines, you always want to use the vocabulary word that they're giving you in the given. Here it was in a symbol form, but it's still a vocabulary word. Perpendicular lines form congruent right angles. That's how I know those 2 angles are congruent, because they're both 90. All right, now that I've used my first 2 givens, I can put a little check mark off on them. I used them, I marked them, I said it, I'm done. Number 3. Line segment AC is congruent to line segment DB. So here's the given that I'm looking at. Now I want to mark it on my diagram. AC is here. I mark congruent segments with the dash. It's congruent to line segment DB. DB is here. I'm going to mark this with the dash. Now this can get tricky because if you forget what the original given was, sometimes you think it's just this little chunk that's equal to this little chunk. And again, that's why drawing the triangle separated usually helps. So again, it's line segment AC. Here's AC on my separated triangle. Line segment DB. Here it is on my separated triangle. All right, I marked it. I am done. We have already talked about how, yes, congruent is a vocabulary word. It means it's equal. But I don't need to add it to my table down below because I already know that those are equal. There's nothing extra for me to say. And now I got to think. All right, I have my side here, line segment AC, I have a right angle on B. I know I need 3 pieces of information. Right now I only have 2 on each triangle. So where's that third piece gonna go? Because I already used all my givens. Well, I can always talk about vertical angles or the reflexive property. I do have vertical angles when I look at the original diagram, right? I have angles here and here, up top and down below, but these don't help me at all because when I separate the triangles, those vertical angles are gone. All right, and I want to show maybe the reflexive property instead. The reflexive property means that I have an angle or a line segment that's the same in both. Well, if you remember from the beginning of the video, my highlighting overlaps down here. BC, BCA, BC, BCD. So it's really line segment BC that's going to be reflexive. I'm going to mark that with an X right now in the original diagram, but I would have seen that anyway if I looked at my separated triangles. BC is at the bottom, BC is at the bottom. It's the same line segment that's in both. So now that I've marked it, I have to add it to my table and say it. Line segment BC is congruent to line segment BC because it's reflexive. It's in both triangles. All right. And last but not least, now I have 3 pieces of information, 1, 2, 3 in the first, 1, 2, 3 in the second. So I'm done. Here's step 4. I'm about to finish this off. So I have triangle ABC, triangle ABC. It's congruent to triangle DCB, DCB. I can also get that information from the proof. They give it to me in the beginning of the question. They give me the first line of information and they give me the last line of information. But I have to now figure out what proof is going to make those triangles congruent. Well, if I go through and I mark the information that they gave me, this would have been like ASS. Oh boy, I don't want to make an ASS out of myself. So instead of using ASS, that means I should really be thinking of HL. All right? I know it's HL because right across from the right angle is my hypotenuse, and I also have a leg that's being marked. Again, I have the hypotenuse and I have a leg that's being marked. So this is definitely going to be HL. You got to remember when you see the ASS, it's really the HL. All right, that's just one way to remember it. Another is, again, you don't want to make an ASS out of yourself, so you know it must be the HL triangle congruency method instead. All right, here's the vocabulary underneath. Oops, just kidding. We have to describe the rigid motion that's being used here. So I'm going to highlight that, describe the rigid motion. So again, if I look at my original diagram up top, if I take this triangle in yellow and just slide it over to the orange, they're not going to match. All right, so it's not going to be a translation. So it's got to be a reflection or a rotation. I'm hoping by now that we can identify this is definitely not a rotation. I don't need to turn this guy around and it will be on top of the orange. That wouldn't make sense. So it has to be a reflection. So let me start off by at least writing that rigid motion. That's always going to get you credit, just picking the correct rigid motion to start. But I have to describe, I have to say where I'm reflecting over. Well, I know that line of reflection should be in the middle. It should be going right down the center. And I'm not seeing a line of reflection here. So let me just, so sorry guys, move this down. I don't see a line of reflection, and that's okay. That just means I have to construct it myself. So I'm gonna put my pointer or my bullseye, right, on the vertex for B, line it up, put my finger on it and hold it in place. Now, if you remember, I'm gonna use the perpendicular bisector construction to do this. All right, bisecting means cutting it in half. That's where my line of reflection should be, right down the middle, right in half. So I'm gonna go 3/4 of the way, right around there. Stick my pen or pencil in and swing. Just kidding, stick my pen or pencil in and swing. It's okay if it goes in the words. Then I'm just gonna turn it around, and I'm gonna put my pointer or my bullseye on the vertex for C. And again, using that same hole, I'm just gonna swing again. Draw in my line of reflection or draw in my perpendicular bisector. And I have to give it a name. I gotta label it something. So I'm gonna call this line L because I don't see the variable L being used in this diagram anywhere. So down below, when I describe what's happening, I'm reflecting over line L. All right. Make sure that you construct it to show that L is just cutting that thing right down the middle. It's going right through E. So I can see that D is the same distance away as A, right? B is the same distance away as C. All right. Jumping to the bottom here. There's our vocabulary. It's nothing new. That's the symbol for perpendicular. You couldn't have made it this far in the unit without knowing that. Reflexive means everything, I'm sorry, not everything. An angle or a side is congruent to itself. And the addition might be a little bit new. So addition means I'm going to add 2 things together and it's going to equal one big segment or one big angle. Okay, it depends on what the diagram gives you originally. So when I add them together, I'm going to have congruent parts at the end. All right, let's flip and go to the next page here. All right, let me line myself up. All right, number 1. Again, I want you guys to take the first minute or two of this question. I want you to identify what's going to be important. If you feel like you need to redraw any triangles, please do that, and then check back when you're done. All right, boys and girls, this is what you should have had to start. So as I look at the given, I can see there's 3 givens here. 1, I numbered it. 2, I numbered it. And 3, I numbered it. All right, I also looked at the prove. The 2 triangles that I'm trying to prove are congruent, overlap, and that makes me very nervous. This diagram just looks a little ugly for me. So I actually redrew the 2 triangles as best I could. Triangle ACE, right? ACE, here it is, ACE, and ABF. Triangle ABF, ABF. All right, if that's helpful to you, I would do that as well. And then I also identified what was important in the givens. So here's my, vocabulary words. I know it's in a symbol form, but that symbol tells me that those lines are perpendicular. They form right angles, 90-degree angles. All right. First step is to always add the given to the table at the bottom, so I did that as well. All right, now I'm going to start using the information to complete the question here. All right, if I look at the first given, I know that I should be getting a 90-degree angle somewhere. So line segment BF and line segment AC. Line segment BF and line segment AC, right? It's kind of hard to see when you separate. So when a question like this comes up, sometimes you need to use the original diagram with the triangles that you redrew to see where those markings are going to go. All right, so here I go. Line segment BF, BF is here, and then line segment AC, AC is here. Okay, so it's really this line segment here, let me highlight this out for us, BF and AC, okay, that are gonna form right angles. So I can put one on either side of F. It doesn't matter. All right. The next is that CE, let me grab a different color here, line segment CE, which is here, is perpendicular to line segment AB, which is here. All right, so again, I'm gonna add the box to show that those are 90-degree angles on both sides. All right, and now that I've added these 90-degree angles, as soon as you mark it, you need to add it to your table down below here, okay? But I need to figure out where these 90-degree angles fit into the triangles that I drew. So let me look back. Triangle BFA was one triangle I had drawn out, BFA. And I can see there's a right angle on F, so I'm gonna add that to my triangle now. I'm gonna put a 90-degree angle on F. Same thing, ACE was my second triangle. I can see there's a 90-degree angle on E, so I'm gonna add a box on E as well. All right, so now that I've finished marking up my diagrams, I'm gonna add that to my table underneath. Angle CEA is congruent to angle BFA. And again, you can use your diagrams or you can use the original diagram. It doesn't matter, all right? And how do I know that those angles are equal? Well, if I look back in my given, the vocabulary word was perpendicular lines. So you always start off by writing that out. So perpendicular lines form congruent right angles. That's how I know those angles are going to be 90 degrees. And now that I'm done with the first and second given, I like to just put a little check because I not only marked it, I also added it to my table down below. So I'm completely done. Now I'm gonna look at the third given, okay? It tells me that line segment AE is congruent to line segment AF. So let me go ahead and start adding that to my diagrams here. AE, okay, pretty cool. It's already in my redrawn. And AF, again, it's already in my pictures, are congruent. If you want, you can always add it to the original diagram as well, here and here. But again, it can look confusing. So whatever is gonna help you guys, it's whatever you wanna do. All right, so I'm gonna actually put it, I'm just gonna look over here at my diagrams. Now we've already talked about the word congruent. It's telling me that those line segments are equal, so I don't have to prove that in my table down below. So I'm actually done with number 3. Okay, so I'm gonna look at what I have. I have an angle and a side. And again, I have an angle and a side. So now I gotta think. I had 2 pieces of information. I know I need 3. I used all the givens that they gave me. So now I need to look for vertical angles or the reflexive property. When I redraw these triangles, I don't see any vertical angles, okay? Again, I know I see them in the image over here, the original image I mean, but these aren't the triangles I'm trying to prove. Same thing, this little guy and this huge guy, right? Not the triangles I'm trying to prove. So vertical angles aren't gonna work. So I know I need to look for the reflexive property instead. Now this can be really tough. Don't forget, we can use the reflexive property on a side or an angle, an angle, an angle, an angle, an angle. Do you guys see an angle that's the same in both? I do. I see angle A. I'm gonna put a swoop or a little arc on A in the first, whoop, a little arc on A in the second. Now, if I wanted to mark this on my original diagram, since angle A is in both, and right now my triangles are overlapping, I would mark that with an X. Don't forget, reflexive gets marked with an X. But I already marked it on my separated triangle, so I'm ready to go. I marked it, now I need to say it. So here we go, let me scroll up here again. Number 3, angle. EAC, we always use 3 letters when we name an angle. EAC is congruent to angle BAF. BAF. And again, how do I know those angles are equal? Because it's reflexive. It's the same exact angle in both. All of angle A is in both triangles, okay? There's no segment cutting it at all, so I know that it's the exact same angle that's in both. And now I'm gonna go back and say, all right, I have an angle, I have a side, I have an angle. I got an angle, a side, and an angle. All right, so this would be the angle side angle congruency method. I am now done. I have 3 pieces of information, and now I'm ready to go to my table. Triangle ACE is congruent to triangle ABF. And again, I'm just getting that right up here. It's giving it to me. And I know they're congruent because of the angle side angle congruency method. All right. Jump over to number 2. All right, this one's definitely a little bit more challenging. All right, same thing. I want you to now try starting example 2, press pause on the video, and once you've given it a try, that's when you can press play, and then we'll go over it together. All right, so as we look at number 2, this is what I would have done to start myself off here. I noticed that there were 3 givens, 1, 2, 3, so I numbered them. I know that the congruent symbol is being used on all. So I went ahead and I just marked that angle 1 is congruent to angle 2 with 1 and 1 swoop. I showed that angle 3 is congruent to angle 4 with 2 and 2. And then I also showed that line segment AB is congruent to line segment AC. Okay, I don't need to necessarily go any further with those givens because they're already telling me that those pieces are equal. I don't have to prove it, I know it, they told me. So I can actually put a check because now that I marked them all and I already said it, because right, the first step is always to write out the givens here, I'm actually good to go. So now I'm trying to just finish up the question. All right. I highlighted out, as you can see, the 2 triangles that I was trying to prove. Again, this was challenging, at least for me, because there were so many different triangles in the picture. So when you color in or highlight out A, B, D, now I can see it's really this top chunk that I want it to be equal to this bottom chunk. It's those 2 big triangles. So it also helps me to redraw them on the side. Hopefully you thought to do that as well. And if you don't need to, guys, don't do it. But again, it's a helpful way to get through the question. All right. Now I want to look at the angles because that looks a little like wonky here. If I look in the pink, I have 1 and 2 dashes. And if I look in the yellow, I have 1 and 2 dashes. All right? Well, 1 dash plus 2 dashes, 3. 1 dash plus 2 dashes, 3. So I know that this entire angle up top should be equal to this entire angle down below. But I have to show that, right? All of this is happening on angle A. So I can't just jump over to my picture right now and say, yep, angle A equals angle A, because it's broken up into little pieces here. I got to add those pieces together and show that they're equal. So that's actually going to be my next step. I want to say that when I take angle 1 and I add it to angle 3, okay, I'm using this top chunk up here, that will be equal, or it will be congruent to angle 2 plus angle 4. Okay, when I add these together, it'll be the same thing as when I add these together. But when I add them together, I get an answer. So I want to show when I add 1 and 3, now I get this big angle, BAD, and that's the one that I wanted, angle BAD. And that's going to be congruent to this big yellow angle down below, CAD. So I'm just going to add that on, CAD. And again, oh, so sorry, guys. I hate when I do this. Here's the camera. Oh, my gosh. Oh, my gosh. All right. And I know that this is true because I'm using addition to show it. All right, so that's step 2. Now I've shown that angle BAD is equal to angle CAD. So I'm going to use one swoop on my triangle and one swoop on my triangle to show those angles are equal. So right now I have side angle, I have side angle. I need 3 pieces of information to say I'm done, but since I used all the givens and I just added those angles together, well, the only extra would be the reflexive property or vertical angles. I actually don't have any vertical angles in this image, so it would have to be the reflexive property. And I can almost see where it's going to be because my yellow and my pink meet at the exact same line segment, which is line segment AD. I can see that it's in both. All right, so on the original diagram, I can show that they're the same using an X, right? They're reflexive. They're both in the same triangle. And then over here, I'm going to use a double dash to show that they're equal because I separated them. All right, as soon as you mark something, you need to add it to the table. Step 3. Line segment AD is congruent to line segment AD. It's reflexive, it was in the yellow, and it was in the pink triangle. It's the same in both. Now, I have 3 pieces of information, side, angle, side, side, angle, side. It's consecutive, it goes in order, and I'm done. Step 4. Woo. Triangle ABD is congruent to triangle ACD because of side, angle, side. Okay, and then last but not least, we have to describe the rigid motion. I'm hoping this one was a little bit more obvious. It would have been a reflection. A translation is not going to work if I slide this down, and a rotation isn't going to work if I take one of these and turn them around. It's not going to work. It's not going to happen for me, guys. So it's going to definitely be a reflection. So down here, I'm just going to add that on. It's a reflection. You're always reflecting over a line. So what line am I going to jump? Well, I'm going to jump over line segment AD. If I take the pink and I just fold it down onto the yellow, it will reflect right over. So line segment AD, line segment AD. Whoop. And there it is. All right. The homework is for you to do on your own. So sorry, lost my wording. It's the last page. Make sure that you are showing all of your work. Do not just write, oh, this looks like it's going to be side, side, side. Absolutely not. They're giving you information that you're going to use to mark the diagram. And just like always, based on the markings, you're going to decide what the proof would have been. All right, good luck. If you need us, send us an email.